Well, hello again, Mr. Bucko here with problem number 4 and 5 from your Geometry Chapter 4 practice test. Number 4 on the screen, where we are asked to plot the point F, which is negative 3, 4, the point G, which is 4, 2, and the point H, which is negative 1, negative 3 on a coordinate plane, which I have right here, and plot their reflection images, F prime, G prime, and H prime, over the line with equation y equals negative 1. So this line right here is going to be the mirror which we are going to reflect this triangle over, which we'll see in a minute. Now we're going to draw the triangle FGH and the triangle F prime, G prime, H prime, and indicate the coordinates of F prime, G prime, H prime, which are the coordinates or the vertices of this triangle. So first thing I'm going to do is plot F, G, and H. So I'm going to plot those points. They're right here. Here is negative 3, 4. Here is 4, 2. And here is negative 1, negative 3. So those points have been plotted, and those are F, G, and H, which I'm told to plot. Now I'm going to draw the triangle, so connect those points. And here's the triangle, FGH. And now I'm going to reflect this triangle over the line y equals negative 1. And remembering our algebra, the line y equals negative 1 are all of the points where the y value or the y coordinate is negative 1. And those points are all right on this black line, because no matter where I am on this black line, the y coordinate is negative 1. This is 0, negative 1, 1, negative 1, 2, negative 1, so on and so forth. And the same thing goes true on this side also. Negative 3, negative 1, negative 4, negative 1. So this black line is y equals negative 1, and that's the mirror which we're going to reflect this red triangle over. So I'm going to reflect each of these points. Point F is looking in the mirror, which is the black line. Where is its image? It's exactly the same distance on the other side. Same with H, and same with G. So if I reflect F, G, and H over that black line, I get their image points right here. This right here is the image of F. Straight through, same distance across from F. This is the image of H. Straight through, same distance across or from the black line is H, and same thing with G. So these are F prime, G prime, and H prime. And now we're asked, what are the coordinates of these points? F prime is negative 3, negative 6. G prime is 4, negative 4. And H prime is negative 1, 1. And that's after reflecting it over the line y equals negative 1. So what are the coordinates? Here they are, right here. Number 5 asks us to draw two lines so that the composite of reflections over these lines is a rotation of 120 degrees. So I'm going to reference something from our book that we talked about in class, where the two reflection theorem for rotations, I don't think we necessarily called it that, but we did talk about this, where if M intersects L, if two lines intersect them, the composition of reflections over L and then M has a center at the point of intersection of M and L, and has the magnitude twice the measure of an angle formed by these lines in the direction from L to M. So, spooky language. All that it's saying is that these two lines have to intersect. So if I'm going to draw two lines, so that the composite is a rotation, they need to be intersecting lines. So I'm going to draw one line, arbitrary line. I can draw that wherever I want. The next line I draw has to intersect it. So I'm going to draw another line that intersects it. Now what's true about these two lines is that they have to have the angle between them has to be half of the degree of rotation. So the rotation is 120 degrees, therefore the angle formed by these two lines has to be 60 degrees, because that is half of the rotation. Because the magnitude is twice the measure of an angle formed by these lines. The angle formed by these lines is 60. As a result, the magnitude of the rotation is 120, as we were asked to produce.